day to all of you. The session is regarding intermediate chemistry, where we are going to discuss about the content related with the intermediate session, and this will be helpful for your entrance examination and competitive exams which you are fetching. You are aspiring for the international floor examinations and India level JE advanced, JE mains examination. This will be helpful for your IIT, NIT entrance exam, that is the technical domain which is applicable all across India. NEET chemistry, that is also valuable for medical entrance examination, that is applicable all across India. Telangana and Andhra Pradesh state governments are conducting MSET examination to make the students to enter into engineering stream, that is BTech or engineering entrance examination. Again, it is the technical domain. In addition, government is going to organize so many examinations. Government career opportunities are available in various fields. There, common question paper will be there related with general studies. There, different dimensions of knowledge checking will be there. Among all, general science will be the content which is common for all the aspirants for the government examinations. There, the content what we are discussing will be very much fetching towards your preparation. Let's enter into our today's session. Explain the optical isomerism of the following compound as per the IUPAC protocol. IUPAC stands for International Union for Pure and Applied Chemistry. RS nomenclature is also known as absolute configuration. R for rectus, S for sinister. Rectus means if you are going from higher priority to lower priority in the clockwise dimension, that is called the R configuration. Anti-clockwise rotation, S configuration will be there. The compulsory condition in order to accompany with the optical isomerism or else RS nomenclature must be chirality of the carbon. Any carbon accompanied by 4 different functional groups in its vicinity. If you go with this carbon, cyano is one functional group, CH2NH2 is another, OH is another, and hydrogen. So that here 4 different functional groups are located. Hence, we can say it is a chiral carbon atom. If the chirality is there, then only you can assign either R or S nomenclature, right? Let's see how can we go for its RS nomenclature. It is somewhat complicated question, we can say. How to solve in a step-by-step manner, let's see. Okay, so this is the carbon around which you can find 4 different functional groups. This is called a chiral carbon, which is mentioned with the star mark. And on this carbon, you have to go for assigning priority. 1, 2, 3, 4 order will be mentioned. In order to give the priority, we have to follow Kohn, Ingold, Prelog rules. According to that, highest atomic number, greatest priority. Here, carbon directly linked with carbon, carbon linked with carbon, carbon linked with hydrogen, carbon linked with oxygen. So that obviously oxygen is of higher atomic number over all the remaining. OH will be given with first priority. Then CN, nitrile will be given second priority. Here also we have CN bond, here also CN bond. Why we are going with CN as the second priority rather than CH2NH2? Because CN bond is accomplished with a triple bond. Triple bond indicated for 3 individual CN bonds. That's the reason why. So here 3 CN bonds are there, here 1 CN bond is there. Obviously you can move towards this CN bond, CN triple bond. So this will be given with priority number 2. And CH2NH2 is given with third. And hydrogen being atomic number 1, so that 4th priority. After assigning all these priorities, you can move in this direction. Whenever you are moving, what happens? It is moving in a clockwise rotation. This is said to be what? Clockwise movement. You are moving from first priority to second priority. This is called a clockwise rotation. But this is not final answer. We are not supposed to end up with this answer only. Because whenever hydrogen or least priority is there, the compulsory condition is least priority group must be away from the viewer. That should be indicated with the dotted line bond. In order to make this, we have to interchange the functional groups. Hydrogen move to here, cyano will come here. Interchange of 2 functional groups that is carried by this knotted arrow. So here hydrogen is coming over and a cyano is shifting over there, right? So the bond positions of OH and CH2NH2 remains unchanged. Only we shifted these two bonds. These two got interchanged. Later on, another one more rotation you are doing, one more interchange of functional groups you are doing. How? Hydrogen will going there and CH2NH2 will going to a planar bond, right? Dotted line bond indicates away from the weir. A single line bond indicates within the plane. Wedge bond indicates towards the weir. This is the 3D formula, three-dimensional representation, right? So that if you interchange hydrogen with CH2NH2, CH2NH2 is coming onto the planar bond and dotted line bond will be the hydrogen. After getting this one, again you have to assign 1, 2, 3, 4 like this. 1 for OH, 2 for nitrile, 3 for CH2NH2, 4 for hydrogen. So in this condition, you are moving in this direction. This is said to be again a clockwise motion. Clockwise motion will give the configuration R. So the given compound is said to be R configurated. So if it is R configurated, how can we give its IUPAC name? IUPAC name of the compound. In order to assign IUPAC name, we have to go for longest chain will be the parent chain. Here, this carbon is also accounted for naming. This carbon is there, this carbon is there. So that 3 carbon chain, propane is the parent skeleton, and you can find obviously C triple bond N will become a higher priority, and the second carbon hydroxy, third carbon amino is there. In order to write its name, so among hydroxy and amino, alphabetical order amino will come first. So that let me mention 3 amino, 2 hydroxy, propane, nitrile. What configuration? R configuration. So that let me give the complete name R, 3 amino, 2 hydroxy, propane, nitrile. This is the way we can give the IUPAC nomenclature for the given compound, right? So this is regarding the IUPAC protocol and RS nomenclature, absolute nomenclature process. Move on to question number 2. Question number 2 is collected from Cambridge Assessment International Education, where describe the test for lithium ions. Lithium ion. Lithium is the metal in the periodic table. It is the lightest metal in the periodic table and highly reactive metal. Highest standard electrode potential is accorded for this one. So that lithium ion find a wide range of applications, especially in the battery chemistry. So that lithium ion batteries plays a vital role. Whatever we are using, the batteries handy are made up of these lithium ions, especially the mobile phones, whichever containing a lightweight battery is made up of lithium ion, right? They're asking for test for lithium ions. What test you are doing? What observation you found? Two are required to be answered. Test name and observation, right? For that purpose, I'm going to give the detailed description regarding identification and confirmation. I'm going to do 2 tests over there. Identification means flame test is the indication for the existence of ion present in that. Okay. So whenever you are taking whatever unknown metal, if that metal is unknown to you, you have to find out what metal it is. So before that, you have to go for its preliminary test. Preliminary test is the fundamental. A minimum idea you will get by this. This is the kind of identification test we can say. After identifying, we have to go for chemical test for confirmation, right? That's the reason why flame test is said to be what? Identification test, and chemical test is the kind of confirmation test. Lithium ion is present, that's subjected to a flame, it will give a red color flame. If you observe here, you can clearly understand lithium when placed upon the Bunsen flame, you can observe the red color, crimson red color flame is observed. If crimson red color flame is observed, you can clearly identify the given ion will be the given ion might be a lithium. Lithium ion may be present because it is the identification only. I'm going for confirmation. How to confirm? By adding a chemical reagent, right? What I felt a lithium ion may be present. Now I am going to go for confirmation test. For that purpose, lithium ion dissolved in the suitable solvent was taken in the test tube that is clamped to the stand. And now I am adding a few drops of phosphate ion solution. Phosphate reagent will be added. You may take sodium phosphate, right? So sodium phosphate solution is added over there. Whenever sodium phosphate solution is added, the lithium ion solution turned into white color. Milky white color precipitate is formed. Precipitate means water insoluble substance. The compound formed will be lithium phosphate. Lithium phosphate existing in white color. That's the reason why this is the confirmation test for lithium. How many tests we did? One is flame test, which gives the red color. Then you can identify it as a lithium ion. You can confirm by taking the unknown solution and dissolved in the suitable solvent added with a few drops of sodium phosphate and it able to give a white precipitate of lithium phosphate. You can clearly confirm that the given ion is lithium ion. This is the way I'm doing the test. Name of the test will be flame test. Observation will be red color. Name of the test will be phosphate test. Here observation will be white precipitate formation. Here for the confirmation, I am going to do the two tests and its observation is also mentioned. By this question number 2 got answered. Let me move on to question number 3. Question number 3 is collected from JEE Advanced 2018 question paper, paper 1, right? The Fisher projection of D-glucose is given below. D-glucose, if mentioned, the question is coming from carbohydrates, organic chemistry, carbohydrates, biomolecules question it will be. Here, any molecule can be projected either in the Fisher formula or else Newman formula, Sahar's formula, dotted line formula, so molecular formula, chemical formula, so many methods, empirical formula also will be there. This is the way so many kind of representations are possible. Fisher is the convenient method. This is purely for chalk and talk method. We can clearly go for the Fisher projection. Fisher projection is said to be a two-dimensional representation. Horizontal lines will be there, vertical lines will be there, right? Only by using this kind of projection, it is possible to locate functional groups in the molecule is said to be a Fisher projection. This is the Fisher projection formula and where D-glucose is given. This is a D-glucose, right? So D-glucose is having the last chiral carbon if OH is present on right hand side, that is called capital D. Why it is mentioned with capital D is, so all 1, 2, 3, 4 chiral carbons are present. Among 4 chiral carbon atoms, last chiral carbon if contains OH functional group in the right hand end, then you can assign D. All the carbohydrates are the part of D carbohydrates. All the amino acids are L amino acids in nature, right? This is the fundamental we have to know. If you are mentioning small d, that is different. Capital D is purely for position of OH functional group. So this OH is laying towards the right hand side, then D, capital D is assigned. All carbohydrates are D, all amino acids are L in nature, right? Now, whenever this D-glucose was taken into the consideration, correct structure of beta-glucopyranose. Beta-glucopyranose to be identified. So, always, pyranose is a cyclic form. It can be represented in a cyclic form. In that cyclic form, this glucose exists in two different isomers. Isomers means what? Molecular formula will not be changed. Only you can slightly change the arrangement of the functional group, that is called isomer. Alpha and beta two isomers are possible. They are specific for correct beta glucopyranose is required to be mentioned. So here 4 different options are provided. Among 4 options, all are 6-membered ring structures only. So this is called ether linkage. Okay, so this is called a six-membered ring called a pyranose ring. If five-membered is there, that is called furanose. Six-membered is called a pyranose ring. On this pyranose ring, beta glucopyranose is required. Okay. If OH is laying upward, that is called alpha. If you see all the atoms, all the ring systems, here we have OH upward, OH upward, OH upward, but only in the option number D, OH is inclined downward. That is purely indicated as a beta glucopyranose. Beta for OH downward direction. So that is given in the option number D. It is clearly mentioned like this. Okay. So D-glucopyranose structure will be like this, where we are having six-membered ring with the oxygen heteroatom and hydrogen upward, OH downward. Here OH upward, hydrogen downward, H upward, OH downward. All are in a alternate arrangement, down, up, down, up again. So up followed by down again. So totally all the functional groups are alternatively arranged. It is very simple to remember. OH is downward, again upward, downward, upward, downward. Very simple to understand. This is said to be what? Beta glucopyranose. Pyranose is the six-membered ring. Furanose is the five-membered. Five-membered ring is given for fructose. Six-membered ring is given for glucose. So the same answer is mentioned in the option number D. From this only clearly you can understand OH, OH, OH. If all are upward, you can cancel out all. Whenever OH is downward, that is said to be a correct answer mentioned in the option number D. For question number 3, option number D will be the correct answer. Right. So question number 4, we are going to discuss JEE Advanced 2018 question paper, paper 1, we collected this. नीचे दी गई स्पीशीज में से प्रतिचुंबकीय डायामैग्नेटिक, प्रतिचुंबकीय इज नथिंग बट डायामैग्नेटिक स्पीशीज की संपूर्ण संख्या है हाइड्रोजन परमाणु, नाइट्रोजन डाइऑक्साइड, एकलक मोनोमर, एकलक इज नथिंग बट मोनोमर, O2 minus superoxide, O2 minus is called a superoxide. वाष्प अवस्था में वितनयित सल्फर, डाइमरिक सल्फर. ओके. वाष्प अवस्था में वितनयित sulfur, dimeric sulfur is taken. Okay. Mn3O4. Mn3O4 is the oxide of manganese. Then NH4 taken twice, FeCl4. Ammonium chloroferrate can be taken. Ammonium chloroferrate. And this is ammonium chloronicolate. Okay, ammonium chloronicolate. And this is potassium K2MnO4. Okay, potassium manganate. K2CrO4, potassium chromate. Okay, so these many compounds are provided among all. So प्रतिचुंबकीय species की संख्या निकलना चाहिए. So प्रतिचुंबकीय species is nothing but diamagnetic in nature. Okay, whenever all the odd electrons are paired up, that is said to be diamagnetic in nature. So they are asking for only number, संपूर्ण संख्या चाहिए. Okay, so number only required, not which species. Okay, number, how many species are existing. Okay, one and only one species is a diamagnetic in nature, that is K2CrO4, and the remaining all are paramagnetic only. Let's see. Here categorization is provided. Anuchumbaki is nothing but paramagnetic nature. How many are there? Mn3O4, NH4 taken twice, FeCl4, NH4 taken twice, NiCl4, K2Mn4. All these are the part of what? Anuchumbaki. That means a paramagnetic. Pratichumbaki, K2CrO4. This is called a diamagnetic in nature, right? So this is K2CrO4 geometry. It is located like this around the chromium. Two double bonded oxygen atoms are there, and here OK functional groups are mentioned. Chromium atomic number is 24, and outer shell valency configuration is 3d5 4s1. 3d5 4s1 में, so d orbital is having 5 electrons, 1 2 3 4 5 electrons in d orbital. S orbital is having 1 electron only, right? But in case of this K2CrO4, the chromium oxidation state around the central metal is +6. Whenever +6 oxidation state is there, what you have to do? 5 electrons from d orbital, 1 electron from s orbital, totally removed. If you are removing 6 electrons, what happens? 3d orbital becomes 0. 4s orbital also becomes a 0. This is completely empty. If empty orbitals are present, what we can say? That is diamagnetic in nature. So that K2CrO4 is diamagnetic due to 3d0, 4s0. Means no odd electrons. If odd electrons present, then only it is paramagnetic. Odd electrons are absent, so that we can say it is diamagnetic. And remaining we will see in detail. Hydrogen atom. Hydrogen atom atomic number is 1. 1 electron is there. If 1 electron is there, obviously it will be paramagnetic in nature because odd electron present. NO2. If NO2 is considered, nitrogen is having odd electrons on its vicinity. So that odd electron species is there. Hence we can say nitrogen dioxide is a paramagnetic in nature. O2 minus. O2 minus is called what? Superoxide. The superoxide is having 1 odd electron in the pi star molecular orbital. If you write the molecular orbital diagram for oxygen, what happens? So 2 electrons will be there. Oxygen neutral molecule is having 2 odd electrons, but O2 minus is the negative ion, superoxide it will be. 1 more electron is added, so that among 2 odd electrons, 1 got paired up, so that 1 electron left, which is called paramagnetic. O2 minus is paramagnetic because of only 1 odd electron in that. S2. Sulfur. Sulfur S2 is taken, dimeric sulfur will be taken. S2 if considered, that is similar to O2. O2 means oxygen molecule. Oxygen molecule is having 2 lone pair of electrons in its outer shell. Pi star orbital is having 2 lone pair of electrons. Then sulfur also having 2 lone pair of electrons in the pi star orbital. Hence we can say it is also paramagnetic in nature. If you go with what Mn2O3. Mn2O3 if considered, where you can find manganese +2, manganese +4. Mn2 +3 is existing in the form of MnO, MnO2. MnO is having +2 oxidation state. MnO2 is having +4 oxidation state. Whatever the condition, all these are having odd electrons. Odd electrons if present, that is a paramagnetic in nature. So that Mn3O4 is also the paramagnetic species. Whenever you take ammonium chloroferrate, ammonium chloroferrate, what is the oxidation state around the central iron? Iron is having +2. If +2 is taken, 2 s electrons will be removed. D orbital is having 3d6. 6 electrons will be arranged in a manner 1, 2, 3, 4, 5, 6. Whenever 6th electron is paired up, 4 odd electrons are present. Due to the existence of odd electrons, we can say it is the paramagnetic. If odd electron is there, you can clearly say it is the paramagnetic. Move on to ammonium chloronickelate. So this is having nickel in +2. Nickel is existing in +2 oxidation state around the central metal. Whenever nickel +2 is there, 2 s electrons to be removed. When s electrons removed, 3d8 will be there. 8 electrons, how can we fill? 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons got filled. 3 orbitals are paired up. 2 orbitals are having 2 unpaired electrons. Unpaired electrons are accounted for paramagnetism. Right? So that this nickel complex is a paramagnetic in nature. Move on to K2MnO4. K2MnO4 manganese existing in +6. +6 means manganese having 7 valency electrons, but manganese +6 means 1 odd electron remains in that 3d1. 1 electron accounted for its paramagnetism, but one and only one compound, that is K2CrO4, where we having Cr +6. Chromium maximum valency is 6 only, right? So 3d5, 4s1 electrons will be there. 3d5 4s1 is there, plus 6 means you can remove 3d electrons and 4s electrons as well. Whenever all electrons got removed, chromium will become 0, 3d 0. If 0 electrons are there, that will be diamagnetic in nature. So this is the detailed explanation regarding paramagnetism and diamagnetism. All are having odd electrons except this chromium, potassium chromate, right? So that is only the correct answer. How many are there? Only one answer is correct regarding this diamagnetic in nature. For question number 4, 1 is the correct answer. Move on to question number 5. Question number 5 is collected from Telangana MSET 2023 question paper. Okay, 2023 question paper, MSET examination. Identify the pair of metals in the order with the lowest and highest E0 M plus 3 M volts from the following. Identify the pair of metals, lowest E0 value 1, highest E0 value 1. Two metals to be identified. We have to take great care regarding the identification of lowest E0 value containing metal and highest E0 value containing metal. And more specifically, you have to check M plus 3 to M means that is having tendency to accept 3 electrons, because it is having plus 3 oxidation state and converted into 0 oxidation state around the central metal. So that 3 electrons acceptance, this is somewhat different, right? Trivalent metals are considered over there. So same question mentioned in Telugu. క్రింది వాటి నుండి వరుస క్రమంలో కనిష్ట గరిష్ట E0 ప్రామాణిక E0 M+3 M వోల్టులతో గల లోహాల జంటను గుర్తించండి, రైట్? సో E0 వాల్యూ కనిష్టంగా ఉన్నదాన్ని మరియు గరిష్టంగా ఉన్నదాన్ని రెండింటిని మనం ఇప్పుడు గుర్తించాలి, right? Let's see the answer. Options are provided. Lowest value is accorded for aluminium. Highest value is given for thallium. Okay. Lowest E0 value is given for aluminium. Highest is given for thallium. So lowest means it is easily giving electrons. Highest means difficult to giving electrons. Let's see. If you observe the entire one, aluminium plus 3, by accepting 3 electrons, here the formation of aluminium metal is possible, because all should be mentioned in a reduction potential value, and it is given as minus 1.66. Minus 1.66 indicated for reduction potential. Actually, aluminium natural tendency is oxidation potential, it having tendency to release the electrons, but electrochemical series must be mentioned in reduction potential. In order to make oxidation into reduction value, there is a negative sign indicated. This negative sign indicated for conversion of oxidation potential into reduction potential. So that negative sign is indicated, right? So this is the reduction potential now, minus 1.66. This will be the least value. And if you observe thallium plus 3, by accepting 3 electrons, it is converted into thallium metal. Its reduction potential value is 0.728 volts. This is highest value. Lowest is aluminium, highest is thallium 0.728, which was given in the option number 1. For question number 5, option number 1 will be the correct answer. So thallium least, aluminium larger, this is wrong one. Gallium and thallium. Gallium is having somewhat higher value in comparison to the aluminium. That's why it is wrong one. So thallium least, gallium highest. This is also wrong one. So that the correct answer will be option number 1 only. Least E0 value is given for aluminium. Highest E0 value is given for thallium. For question number 5, option number 1 is the correct answer. Move on to question number 6. This is the last question of the session. Correct statements about the Buckminster Fullerene C60 from the following are. Buckminster Fullerene C60 కి సంబంధించి క్రింది వాటిలో సరైన వాక్యాలను గుర్తించండి. Okay. Buckminster Fullerene is the carbon containing nanomolecule. Nanomolecules are nothing but that is the distinctive chemistry part, where all the molecules are studied in the extremely infinitesimal diameter size, which is the nanoscale. Nanoscale related with the normal scale. 1 billionth of the meter is called a nanomaterial, right? 10 to the power minus 9 meters is called a nano. That is extremely infinitesimal, but extremely potential based chemistry it will be, right? Nanomaterial examples are Buckminster fullerene C60 will be there, graphene will be there, carbon nanotubes will be there, quantum dots will be there. So many type of compounds find extensive applications in the advanced material chemistry, which are studied on the nanoscale. The advantage of nanomaterials are based on the diameter. If you are changing the diameter, entire properties of the molecule will be changed. In the bulk material, if the molecule is insulator, when it is drawn into the nanoscale, that will become a good conducting material. This is the way the diameter matters for its properties. It will contain the distinctive properties in comparison to the bulk quantity of its own material, right? So that nanochemistry plays a vital role in the application-oriented chemistry, right? If you consider Buckminster fullerene C60, it will be. So what kind of statements are correct? We have to understand. It contains 26 membered rings and 12 5-membered rings. దీని యందు 6 కార్బన్లున్న వలయాలు 20, 5 కార్బన్లున్న వలయాలు 12 ఉన్నాయి. ఇది ఒక ఆప్షన్. It contains 12 6-membered rings, 20 5-membered rings. Reverse to this one. They inverted these numbers. దీని యందు 6 కార్బన్లున్న వలయాలు 12, 5 కార్బన్లున్న వలయాలు 20 ఉన్నాయి. Okay, so this is wrong one. First one is correct only. Right? In this, all the carbon atoms are sp3 hybridized. So most of the nano-based molecules are sp2 hybridized. That is very fundamental to remember. sp3 is no way possible for Buckminster fullerene. So that we can cancel out option C. In this, all the carbon atoms are sp2 hybridized. దీని యందు అన్ని కర్బన పరమాణువులు sp2 సంకరీకరణంలో పాల్గొంటున్నాయి. This is the correct one. Okay, so that we can say option A is correct, option D is also correct, B, C are wrong. Let's see how can we explain this. So A is correct, D is also correct. Option number B is the correct answer. Let's see. Right. So this is a ball type of material. Wherever such a knots are there, those are called carbon atoms. And the entire molecule is taken in the nanoscale. And if you count the number of carbons, 60 carbons will be there. That's why we can say it is carbon made up of 60 atoms. And it looks like a soccer ball. I'm like a soccer ball, it is saying. This Buckminster fullerene looks like a soccer ball. Right, a ball type of material. If you observe clearly, a 6-membered ring is there, a ring system with the 6 carbon atoms, and adjacently 1 2 3 4 5-membered ring is also there. So that here hexagons and pentagons are located in this carbon 60, right? Hexagons called 6-membered, pentagons called 5-membered. If you count them, fullerene contains together 20 hexagons. 6-membered rings are 20 and 12 pentagons will be there. So 12 number of 5-membered rings will be there. Okay, so and it is also called as buckyball. It looks like a ball, no? And being it is a soccer ball type of material, it is also called as carbon buckyball, right? So this is the correct one, what they mentioned in the option number A. 20 hexagons are there, 12 pentagons are there. And move on to another hybridization. If you see the nanostructured material, that might be a fullerene or else carbon nanotube or else graphene. Everything is made up of what? sp2 hybridization. All are the part of sp2 hybridization only. So that what they mentioned in this option number C, sp3 is the wrong one, sp2 is the correct one. So that D option you can tick mark. Okay, so that's the reason why A and D are the correct answers here. So for question number 6, option A is correct. Option D is also correct, right? So by this, we entirely completed the session where various domains of the chemistry got covered over. We got entered into IUPAC nomenclature system. Electrochemistry, physical chemistry will be there. Biomolecules in the organic chemistry, carbohydrates we considered, and this is the part of miscellaneous chemistry where carbon nanotubes, nanomaterials is the kind of a distinctive chemistry branch it will be. This is also covered over. A problematic session we entered into different kind of domains. Inorganic chemistry part, magnetic nature, so general chemistry part, so many things came into the picture, so that I can assure for your best knowledge from the session, and it is more informative if you observe in a clear manner, in a focused manner. You can definitely get the information, and which will be really fetching for your coming examinations. So that I'm sincerely requesting to like the channel and comment which part is important towards your preparation. Share with all the aspirants who are serious about the examinations, and subscribe the channel to receive more such kind of updates in the near future. Thank you very much for your patient listening. Thank you one and all.